Hey guys, welcome back to another episode of Rennch. On today's show, I'm going to show you how to go from a paper template to an OEM quality car part with no experience and no special tools. Gentlemen, we live in a very cool time right now where somebody in a garage can make essentially OEM quality car parts without having to have thousands and thousands of dollars of tooling. Behind me is a 1969 Porsche 911S. It was a race car. I've converted it back into a street car and put a twin-turbo Subaru EZ30R Flat 6 in it. It is an unbelievable car. However, now that there's not air cooling, I've got to figure out a way to water cool the car. So I ordered a coolant expansion tank like this from Racetronics, and I needed a way to mount it in the engine compartment. So in this video, I'm going to show you step by step how I went from a cardboard template to a finished car part that I can bolt right into the car. A couple of episodes, you may have seen me create this bracket for my overflow tank. And what I did is I first started with a cardboard template that I just cut the way I needed it to fit, where I needed it to fit, spaced the bolts where I needed them to. So this is a fairly accurate representation of how I need to mount this coolant overflow tank. I then traced this onto 18 gauge steel, made the bends, punched the holes, and mounted my coolant overflow tank to this. Once I was satisfied about where it was and how it was, well, the next step is how do I digitize this information to get it to the powers that be to laser cut this bad boy out. Step 2, once you are satisfied with your template, with your piece that you've made out of cardboard or metal or aluminum or whatever you're using, you then have to trace it. So this is basically the tracing. Let's see if I can show this thing up. This is the trace of this piece. So with the trace, you have to mark the holes where they need to be and always double and triple check the distance between the holes center to center wherever you need them. You know, you can draw lines, use a ruler, make sure the holes are exactly where you need to, and then measure, typically in millimeters, but if you're an inch person, that's okay too. Measure between the holes so you have exact distances because it's really, really important that you get the distances correct on the tracing. Step 3. Once you've made the tracing, you put it on a flat surface, and I always like to use this particular ruler. You can use any ruler you have, and just put it in the picture. You're gonna shoot a photo directly overhead with as little distortion as possible, and you're gonna put a ruler inside that photo. Why are we doing that? Well, step 4 is why we are doing the ruler along with the photo. Here's an example of my photo with my ruler and all of the dimensions marked down on my tracing. And this leads us into step 4. Now, step 4 is digitizing your tracing. This is what mine looks like. This is the digital version of that trace. And how I got that is I actually had a friend on Instagram, big shout out to Joshua M. Davis, who took my photo, brought it into either Adobe Illustrator or Fusion 360 to trace this thing and mark the holes exactly where they needed to be. So if you can see, the holes are perfect. All the dimensions are correct. I can measure them up against my ruler, which is great. From this, I was able to print it out and then mount it on a piece of cardboard where I can double check that my dimensions are correct. Well, Mike, you say, I don't have Fusion 360. I don't know how to use Adobe Illustrator. Totally fine. Here's what you do. This is, by the way, where we live in an awesome time that we have all of these resources available, even if you don't have a lot of custom tooling. This is where Fiverr.com comes in. Fiverr, Fiverr.com. There are hundreds or thousands of 3D designers on Fiverr that you can hire for 15 bucks, 20 bucks to take your tracing and then digitize them exactly the way that you need to. The reason why we include the ruler with the photo is whoever digitizes the photo needs to know the scale of the part that we are trying to trace. So just because we traced something, the computer doesn't know how big or small that piece is. But if we have a ruler with it, we can say, oh wait, that's 1 inch. As long as I can use the ruler to scale the picture appropriately, we're in business. Because then we can double check and make sure that our printout is exactly 1 inch equals 1 inch. Because what happens a lot of the time is if you try to print something on an 8.5 by 11 piece of paper, it may automatically scale to fit. We don't want that. Very often you'll get like a 97% scale, which is gonna mess all of your numbers up. Alternatively, you could do what we did, which is to include a 1 inch by 1 inch box on the print. And that way I can always double check and make sure that my ruler measures 1 inch to 1 inch. Then I know the scale of the part is correct. Now, if you don't fully understand what I'm talking about, the person on the other end will. They will need to know what the scale is and will very much appreciate that you've included the ruler along with the photo. Step 5, refining your piece. Now that we have the digital version and we know that it's scaled and accurate, I can print it, cut it out, and then make sure that the part, once mounted on cardboard, fits exactly like the one that I started with. Because this thing needs to fit as precise as it possibly can. So in my case, we went through a few iterations of this. There were a couple of holes that needed to be tweaked. There was some design and aesthetic stuff that I wanted, like I wanted to put a logo in the middle of it. What I realized 3/4 of the way through is that this bracket doesn't need to be this big. My cooler actually came with a bracket like this, but I realized if I'm making my own bracket, I don't need this anymore. I can just mount it with the 3 mounting holes that are built into the actual cooler itself. So let me cut the entire thing down a ton. So this was the original idea for that. Again, making notes for the holes being 7mm. I want the logo centered. These are kinds of things that I was able to refine on the drawing, take a picture of them, and then send them off to the designer to make the tweaks. Again, no special tools, no special skills. I just have to go, oh, I need that a little smaller, and I need this thing moved over a little bit to fit the way I need it to. But once I trimmed the fat on my bracket, I started refining and it started looking like this, finally ending up with this. This thing looks super cool. I couldn't wait to get it in aluminum, and that is actually the next step of this process. Step number 6. This is where SendCutSend comes in. Whoever the designer is that you're working with will know how to save a file that SendCutSend can use for laser cutting. So all you have to do is you upload that file to the website. Once that file is uploaded, you start going through the options that you have. In this case, I chose 5052 aluminum because that's aluminum that you can bend. And then once it says, hey, how do you want to bend this? I said I want it to be 90 degrees and I want it to be bent down. Once that was done, I thought, what color do I want this in? Well, since I was a BMX kid, I loved when aluminum is anodized. So I thought, let me go with black anodized aluminum. I think that's gonna make the engine pop from an overall aesthetic standpoint, as well as, I just think it looks cool. It looks very factory when something is anodized like that. So we went from this cardboard part to this beautiful laser cut aluminum part with my little Rennch logo right in it, which is so cool. So what I did on my coolant overflow tank is I put a little square of gold heat tape behind the logo and check out the pop. So this is my final bracket. I've actually not installed it yet, so you guys are gonna be with me the first time I install it. Hopefully it fits as well as it looks like it will, because I've gone through all of these steps. So let's pop it in really quick and I'll summarize all of the steps once again. Oh yeah, that's like butter. Check that out, kiddos. That's awesome. Deck lid closes great, no problem. I can get to the cap, no problem. To fill it, it's easy. It's higher than everything, so shouldn't have any air bubbles. And I'm super pleased with it. I think it looks fantastic. So to summarize, You don't have to have tons of custom tooling and hundreds of thousands of dollars of CNC machines and laser cutters and things like that. You don't have to have a degree in 3D modeling. You can do all of this with your own hand tools, a Bic pen, and some 8.5 by 11 paper with some cardboard. Get it to the people that can fix it, and then fire it off to SendCutSend to get a custom car part made that in previous years would literally have not been possible. So again, step by step, cardboard template number 1. Trace your template number 2. Take a photo of your tracing with the ruler included in the photo. Use Fusion 360 or Adobe Illustrator or Corel Draw or whatever you have to digitize that photo to scale. I also love to use Fiverr.com. Refine your piece, go back and forth, make sure every single measurement is exactly where you need it. Once it is, fire that file over to SendCutSend. Choose the options you want to laser cut, to bend, whatever metal you like it to be in, to anodize, to powder coat, whatever they do, because they do a lot of awesome stuff. And then you wait with bated breath until that SendCutSend order shows up in your mailbox and you have a beautiful custom OEM quality car part. That's it for this one. If you guys have any questions about this process whatsoever, fire me the question in the comments and I'll be happy to answer anything I physically can. If you are a candidate for a Subaru engine swap, meaning you have a Porsche 911 or 912, it's got a bad engine, or you just want 300 horsepower to rock while your engine is getting rebuilt for 2 years, hit me up. I've got one more slot available at the discounted beta tester rate. I'll talk to you guys next time.